Okay, so the first thing which I want to cover is the solid principle. Okay, so any interview you
Mm.
go in your level, at least basic they will go for solid, right? We have other principles
Right.
also, but at least you are able to explain the solid. That is enough, right? So suppose you are going for a
Mm.
3 4 years of experience, then they will ask, okay, you explain anyone, which is your favorite, right?
Mm.
But in your experience,
Mm.
they can pick up anyone, right, from this solid.
Mm.
So have you heard about solid before?
Very little bit, yes.
Okay,
Recently, I've gone through it, but
okay,
not in very detail, just
okay.
in outline.
Okay, so in this call, right, we'll go to each one and we'll go in depth so that it is in your mind,
Mm.
okay? Because they will ask
Right,
about the example also, right? So Solis is a principle
right.
not like every developer should follow, right? That's how
Mm.
we can
Mm.
write a better code, right? The architecture
Mm.
is very high level. Before that,
Mm.
the code which you write, that should be
Concepts,
structured well, right?
objects.
If that is
Right,
not
right,
structured well, how will write a better code architect, right? Architecture kind of
right,
thing. Correct.
right.
So the
Yes.
solid principle, the first one is say SRP, right? Single responsibility
Single
principle.
responsibility principle. Right.
So what is saying is very simple that one
A
class should
class should
have
have
one
only one
responsibility.
reason.
Yeah.
Right.
Suppose if you want to change anything, you should have one reason to change it, right? So if you
Right.
understand this one properly, then when you write a
Mm.
code, right, what you will do,
Mm.
whenever you see the functionalities, you will start writing different classes. Okay. So why it will coming in the bind as a developer, you think, okay, why I'll create so many class file .cs file is not required. Put everything on single file, right? People always try to do
Mm.
shortcuts, right? So when you follow these
Mm.
principles, you will not go to the shortcut route. You write a better code, right? You know, yes, I know the solid principle, single responsible. I should write a different classes. Though it will take
Yes.
multiple files, right? So that's the mindset,
Mm.
right? Now, if I go to
Mm.
the example of this, so I already created examples. Okay, so that's why I say these codes are customized. Okay, based on the topic and all. Okay, so let's go
Mm.
for the single responsibility principle where this is getting violated. Okay, so just example. So
Right.
this kind of example you can tell in the interview also. Okay, so suppose I
Right.
have one invoice class, right? The invoice class has invoice amount, invoice date. These are the parameters, right? And
Mm.
these are the different functions. So functions is
Right.
nothing but this class functionality. So we have add
Right. Right.
invoice,
Right.
we have
At
delete invoice,
delete invoice,
and we have
yeah,
send
send invoice
invoice
email.
email, right? So that
Right.
means that this particular class will do three tasks. One is the add
Mm.
invoice, delete invoice, and send email, right? And in
Send
between you
invoice.
can see the logging also, right? Now,
Right.
yes, this is required from the invoice perspective. We need all this functionality, but these are the thing we
Mm.
don't need in a single class, right? Suppose see the
Mm.
logging, he is directly doing logging in a file, right? So file
File.
logging
Right.
nowadays nobody does that, right? They do
Mm.
in the
Mm.
database
Mm.
level or some other libraries
Right.
are there, right? So maybe this is a
Right.
very
Right.
old code and they want to change it. So what they have to do,
Mm.
they have to come to the invoice class and they have to touch the code,
Yeah.
right? So for
Yeah.
logging, they are touching the class. This class is
Mm.
for related to invoice, but he is touching the
Invoice.
class for logging, correct?
Log. Right.
Send email, he
Right.
will write the SMTP server code,
Listen to it
if PDF.
directly.
Yeah, right.
Yeah. Yeah.
So
Yeah.
again, he
Right.
need to change some SMTP server port and all. He need to touch the
Mm.
code. So we are not
Right.
following the single responsibility principle in this class, right? So how we can
Mm.
resolve
Mm.
this one? Obviously, we can break the class in a multiple way, right? So what you will do?
Right.
Obviously, as of now, when you microservice think about microservice, think about interface. Okay, we'll come to the solid other
Mm.
principle. That time it will clear. Okay, so we'll create a logger
Okay.
class which will responsible for the logging, right? So you need
Right.
file logging, database logging, all those concepts will
Mm.
come in the logger class, right? Then we'll have
Mm.
one
Mm.
mail, send mail, right? So
Mail.
all,
Right. Right.
right? And then in the invoice,
Okay.
we'll reuse those. So the big
Mm.
class, we
Mm.
break it in small parts based on their
Got it.
functionality, and then we
Yeah.
implement it. So this is called nothing but
Yes.
single responsibility
Single
principle.
responsibility principle. Yeah.
Correct. So once you
Right.
understand this topic, you can create the example by yourself on the run, on the interview,
Right.
right? Something like that. So that's why the understanding is required. So this is your single responsibility principle. Then
Right.
O is open close, OCP, right? So the
Right.
class should be open for extension and close for modification, right? So the
Mm.
class which you write, you should not touch that, you should not change the code, right? So
Right.
so now the context, this is the principle. Now where the context fitting here? Suppose if you are working on a maintenance project, right? So maintenance project,
Mm.
somebody already wrote some code, right? And those
Mm.
codes
Right.
are already tested code, right? And
Mm.
some
Mm.
defect
Right.
comes and all, you coming and changing the main class, right? So suppose if you touch
right.
the main class, or suppose enhancement came, defect anyway you have to touch the main class. Suppose enhancement came, right? And when the enhancement came, you
Mm,
thought by analyzing the code, you thought, okay, if I put this two line in between in this class somewhere, work is very easy, right?
mm,
So from the developer
right.
perspective, you
That
always
is,
try to do the shortcut thing, right? So yeah, so that's what I
yeah,
said the context, right? So now if you do this
right.
change, you are breaking the open close principle. Why? Because that class has already tested, right? And we are saying this class is closed for modification. You cannot modify the class.
Right,
You can extend the
right.
class, and yes, people
We
do
can only inherit the class.
inherit the class. People
Yeah.
do this mistake, including me also, right? Because
Mm.
everybody, that's the
Mm.
developer mindset, right?
Yeah, yeah.
How
Generally, yeah, yeah. We do that, right?
correct.
Yeah,
So that is the open close principle. Now, if I go for the example, right, see that open close principle
right.
half violet. So I wrote code such a way
Mm.
that, so obviously now the architecture mind come into the picture, right? So when I am the
Mm.
architect and I'm writing this kind of code, that means because as the
Mm.
architect you have to think about future also, right? Change
Mm.
is the
Mm.
constant,
Right.
right? So you have to think that it is
Mm.
gonna change. So suppose something is gonna change, how the other people handle, that's the community, that's the mindset, developer mindset, right? That you don't think I write the code then forget about other developer, whatever. It's not like that, it's community, right? So you
Right.
as a
Right.
good architect you have to think and you write a code, right? So see, this code is not good, right?
Right.
Because they, as of
Mm.
now, the current requirement is there is final invoice and there's proposal invoice, and they told the 100%, the 100 rupees discount and the 50 rupees discount, right? So that's why he wrote the code here, right?
Mm.
So this is
Yes.
clearly violating the OSP violation, right? So how to solve it?
Mm.
So we'll again break down that one, right? So we'll create one abstract virtual override, those kind of inheritance kind of what you mentioned, right? So invoice will
Mm.
be there and it
Mm.
will be a virtual method called get invoice document and one basic implementation, the base implementation. Now different invoices will inherit that and they will override this
Based
function,
on
correct?
right.
And so
Right. Right.
before it was final and proposed, so the third one we already added called recurring, and the percentage is different, right?
Mm.
So see,
Mm.
if I break my
Right.
code in an interface way, okay, then I
Mm.
can solve the
Mm.
OSP principle. So this is a gist,
Right.
right? The knowledge, the principle
Mm.
context
Right.
is fine, but when you implement it, how to implement, that's the main part. That you have to break it in multiple
Mm.
interfaces or abstract class, anything is fine. And you have to give a base
Mm.
implementation through virtual. Virtual means anybody can override if they want. If they don't want,
Override the
I'll keep
methods.
using. Correct?
Yeah. This
So
is
this
inheritance, right?
this is
Not
inheritance. This is
interface.
inheritance. Correct?
Right.
Yeah.
Right. Right.
So this is nothing but open close principle. Then least scope
Right.
substitution principle. So whenever some people what they will just avoid these two because this is very simple. Anybody can explain. They directly jump to the least scope substitution principle. This one
Let's
is a
go.
little
Mm.
complex, right? And
Mm.
here is
Mm.
the main
Mm.
thing will come. So what is saying is that derived class must be substitutable for their base type without altering the correctness of the program. That means whenever there is an inheritance, right? Parent class and child class.
Right.
So the
Right.
derived
Yes.
class can be
Yes.
easily substitute with their parent. So that's what they're talking about. Okay. So let's understand through the
Mm.
example. Okay. So
Okay.
simple example I told, right? So I have one apple,
Mm.
okay, which is wrong, right? See the apple
Right.
has saying the color red, right? And apple and orange is
Right.
inheriting the apple, okay, and he's saying
Yeah.
based on myself I change the color as orange, okay, and you are saying yes,
Mm.
my
Right.
code is fine, my code respect the list of substitution
Yeah.
principle, right? So what I'll do, yeah, apple is parent, I know, so parent is the container, in the container I'm putting the
Mm.
child is my real object, right?
Child is
So now if
right.
you do the apple
But it
dot
is not.
get color, you will get red, right? Correct.
Mm. Right.
You should get
Right.
orange because the orange that's easily substitutable, right? So how we can do
Mm.
that? Again,
Mm.
it will be solved like an interface kind of thing, right? So if we go to
Yeah. We
the
have to
so
introduce a base
base
interface
class,
instead of
yeah. You can do
base class.
abstract.
Right.
So there is one more concept that it will come that
Right.
when we learn the dependencies, right? Dependency injection.
Okay.
That's the
Dependency.
can we replace interface with abstract? Because anywhere
Mm.
in all the places you see the code, always interface, right? So can we do that?
Mm.
People don't
Mm.
generally do the abstract. Interface is easy because there is a contract kind of thing. I'll come to that part. So
Mm.
here we create one
Mm.
interface
Mm.
called fruit,
Mm.
which will say the get color. Now
Right.
whichever class want to use it, he need to inherit it, correct?
Right.
And the
Right.
container is interface. See, the container is interface,
Right.
not the class. Before it
Right.
was class, right? So that's
Class.
what
Yes.
the so that's why it will work now, because interface don't have
Mm.
any class has an object. Interface don't have any instantiate properties, right? So it's just a
Exactly.
container. So
Yeah.
that's
Yeah.
why in the fruit, if I put orange, it will work like orange. In fruit, if I put apple, it will work like apple.
Apple. It will. Right. Right.
See the,
Right.
how when you go to example, how easy to list cost substitute. But
Right.
if you just go to the definition, it's total
Yeah.
confusing. So that's why people
Yeah.
jump
Yeah.
to
This is
LSB.
very good.
This yeah. So they will
Right.
just go
Right.
and say, "Can you explain LSB?" Okay,
Mm.
this is the
Mm. Mm.
list cost substitution principle. Then the fourth
Right.
one again, interface segregation principle. So it is one kind of SRP, means they are saying that don't put all the functionalities to a single interface, because from this
Mm.
four we understand, yes, now from this one I can get a sense that every time I have to use interface, right? If I use
Mm.
interface as a good code, right? So this one is saying
Right.
that yes, you have to use interface, but don't put all your functionality to a single interface. You segregate the thing, correct? So
Mm.
why they are saying like that? So if I go to the ISP violation, right? Where is my active violation? Yeah. So here you can see I created interface, because from my previous core principle I learned, yes, I have to create interfaces. So I create one interface called I printed task, right? So which will
Mm.
print, which will scan, which will fax, and which will do the printing duplex, means the both side printing, right? Now I have one
Right.
class called
Right.
HP LaserJet printer, and I inherit this and I'll override this function. Obviously, when you inherit
Implement
any
the.
interface, you have to override all the function, otherwise it will get error, correct? So
Right. Right.
I'll
Right.
overwrite it. Correct. Solve the
Right.
functionality. Then after some time, I got a new requirement called liquid inkjet printer. Okay,
Mm.
and
Mm.
I'm
Mm.
in inheriting this.
Inheriting the same
Same, but
interface.
here I figure it out. This particular thing, fax and
Mm.
both side printing is not available. Basically, it's only do the print
Mm.
and scan. But now, if I inherit
Mm.
from this interface, I have to
Have
implement
to
this.
implement.
Correct. So
Right.
this I am
Right.
forcing. This I am forcing
Mm.
my client. No, this is the contract. You have to use it. So
Yeah.
that means
Right.
somebody will instantiate object from here. He will think about it will do print, scan, fax. Is correct. He will do it.
Right.
Again, some client
Mm.
will inherit. Sorry, the create a object of this one,
Create objective.
and he will think it will do print,
Try to
scan,
use
but it will
facts
not do
and
fax
print
and print
duplex.
duplex, right? So this is not
Right.
good. So this is the violation of ISP, right? So they are saying
Mm.
segregate.
Mm.
It means segregate means different, right? So how we can solve it?
Right.
We'll create multiple interfaces. It's simple only, right? The concept. So
Yes. Yes.
the core part which is common, you keep put it in a single interface, and which are
Mm.
different. I break and I create a, because in C sharp there is one
This.
more question here.
These
Multiple
things
inheritance
might be
possible.
optional.
Yeah, multiple inheritance is possible. Answer is yes, through multiple interfaces, right? So I
To
will
multiple interfaces.
yeah, so I'll inherit those
Yeah.
interfaces where I have the
Mm.
proper task available, right? So suppose HP
Right. Right.
LaserJet, I inherit all the interfaces, right? For
Mm.
my this
Mm.
one, I just do the base one. I don't have this
Whatever
functionality,
basic. Yes.
correct?
Yes. Yeah. Right.
Because in the
Right.
before we already learned that the client will not create object based on this class. They will create object for the interfaces, right? So
Mm.
they will
Mm.
put the
Right.
containerized interface. When they will create the ink jet printer, they know you have to create this, and this interface has only two functions, so they will understand, okay, it will only do print and scan, correct?
Right.
Whereas this
Right.
one they
Right.
can understand all. So this is called the
Okay.
interface segregation principle, right?
Mm.
And the
Mm.
last one is
Right.
also very important. This last three is basically
Dep-
important. First two are very easy. That is dependency
mm.
inversion principle, right? So dependency
Depends.
injection is the concept which is used nowadays everywhere. .NET, Java, wherever you go,
Mm.
right? Java have a
Right. Right.
Spring Boot. Nothing but dependency injection
Mm.
only, right? .NET Core and all.
Mm. Right.
Inside they have the dependency injection implemented. So they are
Right.
saying the
Right.
high level module should not be dependent on low level module.
Low level
Both
modules.
should depend on abstraction, right? This
Mm.
promotes the
Mm.
decoupling through this. Okay. So my suggestion would be, when I take interviews, what prefer is, don't think that okay, this is not important. Both thing is important. Mean
Mm.
whenever they'll ask, can you
Mm.
explain dependency? Like in your school, you just remember the thing, na? Just you remember this thing, right? You tell it.
Yeah.
Yes,
Yeah.
you are
Yeah.
good with the definition. Then they will come to the example, and both way it will be correct.
Mm.
Some people I see, they are
Mm.
not able to not able to explain the definition, but they are good with the example,
right,
right? But
right, right.
what prevent us to memorize it, right? Because it's always presentation is good, right? How you present yourself in the interview.
Mm,
I'm
right.
all I am concentrating how you need to clear, right? How you need to give better interview.
Mm,
When you are in already
true,
job,
true.
this thing is not required. Only need is a concept. But in this scenario, you
Right.
have to remember. So you have to just memorize this, then come to the example. Both way it will be fine. So dependency, they are saying that there is a high level module and low level module, right? So what is high level module? Like higher level class. Suppose if you go to your three tier architecture, right? Your UI is
Mm,
dependent on the
mm,
business is dependent on the DAL layer, right? So DAL layer is kind of a low level
mm,
module, business is higher level
right,
module, while business is low
right.
and UI is higher, right? So there is a dependencies there.
Mm,
So this dependencies,
right,
they are
right.
saying it should not be totally dependent, it should depend on some abstraction. Okay, so let's see what is
Mm,
that saying as an example. Okay,
okay.
so see here, the same three-tier architecture only I implemented. See, I have employee class, which is nothing but entity
Employee.
class. Okay. Then I have a
Right,
data
right,
access logic, which will just give the
right,
data. Think about it, will create a new employee and give it. Okay. Then I have a
right.
data access factory where is returning this access logic, and I have a business
Access.
layer. I am calling
Yeah.
this access logic. Okay, so see what I am doing it. I am directly calling. I am see directly instantiate, right? So
Right.
this is dependence. Now my employee
Mm,
business
mm.
logic is totally dependent on the
Depend on
data. Okay.
employee. Right,
So
right,
our
right,
high level module in low level module tightly coupled, which is wrong.
right.
They should
Mm,
depend on some abstraction. Again, abstraction
mm,
means nothing but interface. Correct? So how we'll
right,
solve
right.
this problem? Right, so what we'll do, we'll create one interface, right? So each one I create an interface
Right.
and class will
Interface.
inherit this, and this interface will inject as a dependency. Correct, so that's why it is called a dependency injection. So who will inject these dependencies? The dependencies are injected by the frameworks. In .NET you have .NET is core and .NET 8.0, those are the frameworks, right? So the
Mm.
framework has a, because you already, oh, you worked on .NET core.
I no, no,
Okay,
not on
so
.NET
we
Core.
okay, so okay,
Mm.
so we'll cover those, right? So .NET Core,
Right.
you have to just write the dependencies. Okay, that in my code, whenever somebody need the data employee data access logic and is dependent on
Right.
interface, I'll provide the instantiate. Okay, and there are multiple options
Mm-hmm.
are there. Singleton instantiate. Okay, there is a request
Okay.
per call SSL. So these are the framework is providing that I will provide you the
Mm-hmm.
dependency. Through what?
Right.
Dependency can be injected in three ways. One is constructor way, another is method parameters, another is setter getter. Many ways we'll do, but people generally prefer in the constructor way. So we'll cover all those things.
Mm-hmm.
But from the
Right.
dependency inversion principle logic side, that you have to create the interfaces, and the class should be dependent on the interface. Interface is nothing but abstraction because it don't have any
Right.
implementers and it has just the abstract method kind of thing, right? That yeah,
Mm.
this
Right.
interface,
Right.
whoever implement this interface, he will provide me some data about the employee. How he will provide, I don't know.
Mm.
Correct? I
Mm.
only know about the
Mm.
interface. So that's why
Mm.
interface is used as a contract, right? So when
Mm. Right.
somebody is
Right.
using this interface, he knows that yes,
Mm.
I have this
Mm.
contract. I am sure somebody will give the data.
Right.
Okay,
Right.
implementation is hidden. That's why it's
Mm.
abstraction, abstract, right?
Mm.
So these are the
Mm.
gist of this solid principles.
Can I have a look at the code once?
Yeah, which
The
one?
salt, the salt, salt DIP. Yes.
Okay,
Yeah,
yeah.
this one.
Hmm.
Okay. So first we have interface. Then we implement it to this class. That is fine. And then we have data access factory, and in data access factory we have a static. Okay, that returns this. Okay, it returns interface, but actually, like, yeah, the
Yeah,
type is interface, but
correct, correct.
actually it is returning the
This is
object.
list scope, right? Yeah,
Right,
I can do this one, but that is wrong
right.
implementation, right? So these are the thing you have to write code. When you understand this
Mm,
principle, you write a
mm.
better code. Correct.
Right, right, right. And can I, yeah, see the below code as well,
Yeah.
like the main business logic,
The main logic. Yeah.
employee
Yeah.
business logic. Okay, so we have created
Because here is the main thing. See the dependencies. Here is the main thing, right?
yeah,
Here
right,
is the
right,
main
right.
thing.
So here we get the
Correct.
data access factory,
Yeah,
and that's fine.
because I
And
stop at the business level. Main is that there is no UI, so this is the main. Okay?
right. Got it. So here,
So
uh,
what generally do is this is the
mm,
normal
mm,
implementation from the
right.
and how the .NET Core works is they put like this. These dependencies they
Mm,
put in the constructor like this, okay, and they
right.
don't have this one. So the .NET
Mm,
framework automatically provide the object, and you can directly use it.
okay,
Okay, so that is the .NET
okay.
Core. Okay, here I say I am just
Okay,
specifying by myself that create new.
right,
This is the new one, na? Data access factory means new. So this new
right,
keyword you
right,
should not use. Any dependency
right.
ingestion framework you are using, you should not use new. That framework will give
Okay,
you the object. That is the main code. And they
okay,
will maintain the
okay.
life cycle, right? There is a life cycle.
Hmm.
Suppose this
Right,
particular object I need
right.
for a par session. Par session means when I'm running a web application, sessions are
Hmm.
there,
Hmm.
right? Session request, you know
Right,
that.
right.
So
Yes,
it
yes,
is
yes.
par request. Par request
Hmm.
sorry, one session can have multiple requests, right? You're going to home
Right.
page, you are going to
Yeah, right.
dashboard page, right? So do I
Yes,
need to
yes.
hold this object lifecycle for whole session? Okay, based on the
Hmm.
requirement,
Hmm.
or I will
Hmm.
hold the life cycle of each session. New session, new object will be created. Copy, right? Or
Hmm. Because
single
of new.
yeah, or
Otherwise, yeah, we can do a singleton, right? Right.
singleton. Suppose you need one
Right.
functionality for singleton, right? So
Right.
when
Right.
the whole application start, the object
Hmm.
created and the object will
Will
sit
be
in the memory.
instantiated.
Sorry.
Yes, it will be. I worked on singleton in WPS
Okay. So this
case.
WCF, WPF are already old, so I'll cover those things. So SRP is
Yeah.
okay. So what you can do anyway, this is a recording session. You go and take notes. Anything is not clear,
Right.
and
Right.
then
Right.
again we can
Sure.
go through again in the next session. Okay. So this is
Sure.
solid principle. So my suggestion, by
Got it.
heart all this definition and then the example. That
Yes.
will
Yes.
be enough. Okay.
Right. Okay.
Now let's go to your microservice side. Okay. So
Right.
tell me, is your experience? Have you worked on the web application or only Windows application?
No, web application.
Web. So you worked on the
Yes.
SPX pages, right? MVC have you worked
Yes,
on?
yes, yes. A little bit MVC.
Okay, the normal
I worked on
waveform, the waveform mainly you worked on, not on the MVC side much,
no
right?
with Angular JS. I told
Okay,
you, right?
so you
Yeah,
created
Angular
web
JS.
service, web APIs?
Yes. Web
Okay,
services, and also I worked on even MVC little bit on some projects. We had MVC implementation, so I worked on ASPX web form and also MVC as well.
okay. So the web API you created in .NET 4.5, right?
Yes.
And those are RESTful web APIs.
Yes, they are RESTful. Yes, that's
Oh, okay. So
right.
this RESTful web API you need to cover. Okay. So if you're knowing that's what is RESTful, how many RESTful
Hmm.
bars are there, right? Get, put,
Hmm.
post,
Hmm.
and
Hmm.
delete, right? Do you know the
I
difference between
worked
put
with
and
this.
post?
Uh, okay, different between put and push. Basically, we
Correct.
can do everything with the post actually,
Ah.
but the difference is with the put is particularly
So
used
this,
for changing actually, like
yeah,
for
correct.
updating an
Correct. So this
entity,
is yeah.
right?
So this is one important question. So put basically will go
Right.
for the update, right? So
Update. Yes.
post we can write a logic such a way that if the record is there, it
Yes,
will
we can.
update. If it is
You're
not
right.
there, it will create, right? People generally
Right.
follow this
Right.
kind of principle also. But the
Right.
rest saying is that always go for create for
Yeah.
post and go for put. So when
proper HTTP verbs
correct.
we
So
have
when
to
you
use.
explain this way, right, they will say, okay, you have
Right.
the knowledge also, you have the real knowledge also, right? Because the
Right.
theory and real
Right.
is different, right? So that's what I told.
True.
Post, many people write
True.
learn. So when you explain this
Mm,
way, they will get the confidence. Okay. So
mm,
restful, you know. Okay.
mm.
Now let's go for the so these are the couple of architecture styles. So I think you are already worked on the monolithic. Okay, so
Monolithic, yes.
monolithic
Yeah.
application. So what is the monolithic application? The monolithic application means big application, right? All
Mm,
these
mm.
web API, whatever you created in a single project, basically. Things about let's talk
Right.
about the .NET side. Okay? So single project
Right.
you create. So that's why it's a monolithic application, right? Now the monolithic
Right.
application can be also a layered architecture. Layered means you have a three-tier
Mm,
architecture, right? Different layers.
mm.
So
Right.
entire, then it could be a client server also, right? In your case, client
Mm,
is AngularJS, but somebody is creating, suppose, the web form application, right? Then client and server,
mm.
everything in a single application. So that's also a monolithic application, right? Component based or
Right.
plugin play, suppose Windows application kind of thing, right? So you can create
Mm,
different
mm.
different component. Okay, so all these are kind of architecture style which can be implemented in
Mm,
a monolithic. The logic meaning is the big, right? Then
right.
the after the monolithic, like before the microservice, there is a one more concept was there, SOA, service oriented
Service
architecture,
oriented.
okay, where your WCF come into the picture, right? So
Mm,
SOA
mm,
architecture has 4 or 5 principle. I already forgot it. Long time I did it. So that service oriented
mm,
architecture. Now the cloud native where microservice are event driven. So this is the updated part
mm.
now. People are working here. So see, this is the structure.
Right.
Okay, so here I have a diagram
Right.
also, right? So
Right.
first it was a
Yeah.
monolithic where all your backend, front end database is sitting on a single
Database.
server, a single box. So
Right.
that's why it's a monolithic. Then we changed to
Mm.
came to a service oriented architecture. So
Service
you're
oriented
breaking it to
architecture.
service level. Okay, what are the services are there?
Mm,
You figure out the
mm,
services, then we'll put, and here the enterprise services, nothing, the WCF implementation was there, a SOAP
mm,
architecture that
mm.
communicate between the SOAP, the WCF was coming into the picture from the .NET side I'm telling,
Right.
right? Now
Right. Right.
here
Right.
the microservice coming into the picture. So what is microservice?
Mm,
Microservice is nothing but the monolithic you are breaking is small services, right? So suppose the
mm,
big service is
mm,
there, okay, and
mm,
you already first how you have to do the exercise, okay. Suppose there could be
mm,
one thing, scratch development, right? So they got the
mm,
requirement, they want to do the scratch development microservice.
mm,
So
mm.
obviously they will go for the microservice because that's the hot topic, right? So they will figure
Right.
out, okay,
Right.
what are the areas, what are the domains, what
Mm,
are the functionalities, this particular. So the brainstorming session will be there, right? And they will figure
right.
out, okay, this is the different services. So each
Right.
service in a layman term, if
Right.
I say, they will create a different project, simple, in
Mm,
.NET.
mm. Right.
Okay.
Right.
Suppose in the
Right.
.NET side, there is no
Mm,
saying, no such principle that all the services you have to create in .NET. Suppose big
mm,
application, Amazon, Netflix, right? They may create
mm,
services
mm.
in different language, right? One service in Java
Right. Right.
language, one service in .NET, one service is Golang, one service
Mm,
Node.js, one service Python, all,
mm.
right?
Right.
Because
Right.
when you
Right.
break the
Right.
thing, each individual can see functionality is functionality. The
Can be a
language
right.
is different, right? So they will
Right.
break it and they will decide. But one more
Mm,
concept. Suppose you are already working on existing project and which is your .NET
mm,
4.5 monolithic
mm,
application, right?
mm,
Now your
mm.
project
Right.
manager thought, okay, now microservice is very hot. I want to convert to a microservice, right? So
Mm,
that will be a different approach there. Correct.
right.
So there are
Mm,
different
mm.
approach. I'll explain it down. So in interview, when
Okay.
you explain in this way, they will get a feedback.
Okay.
Okay, you have worked on both kind of thing. What is that's called a
Mm,
greenfield project. Greenfield means the scratch development. You are starting as a green,
mm,
everything green. This is very easy,
mm.
right? See, to
Right.
understand
Right.
other code is very difficult. Writing a fresh
Right.
code is easy. So
Yeah,
very
that's
easy,
true.
yeah. So
Right.
you can explain in both ways. Then they will say, okay, you have the experience on both, right? So microservice is nothing but we are breaking the whole application in small chunk. Okay, that is nothing but the
Mm,
microservice. I will come to the different architecture, but in very layman term, when the microservice what come to your mind, you think small services working together and giving the same
mm,
kind of service. The monolithic was
mm,
doing the same thing, right? It has a product. Suppose a banking application, it's a product. The
mm,
whole
mm.
functionality is single project, right? But it has all the
Right.
functionality. The same functionality my microservice architecture will do, but in a better way.
Mm,
Correct. Some of the problem
mm,
I will discuss some of the problem in monolithic which the microservice will
mm,
solve. Right? Why people is coming in microservice? Because see, maintaining multiple service is a tough task, right? See,
mm,
handling
mm,
single project is
mm,
very easy. Then why people
mm,
still going to
mm.
the microservice? Obviously, microservice has some advantages, right? That's why people are going
Right.
microservice. Correct.
Right.
So we'll come to
Right.
that. And then
Mm,
serverless. Serverless is a cloud concept where they are saying, see, server obviously required. Without server, no code runs, right? But serverless
mm,
concept is like you don't think about the server. Okay. I
mm,
will
mm,
provide, you just write some code and your code will automatically
mm.
start. Okay. So the microservice
right.
code will automatically start because in cloud there are different SaaS is there,
Mm,
service as a
mm,
then PaaS is there, platform as a service,
mm.
okay, infrastructure
Perfect.
as a service,
Right,
okay. So serverless
right.
will come under SaaS, okay, software as a
These
service.
are functions, right? Like Azure
Functions, Azure
functions, right?
functions, correct. Okay, so this is serverless.
Right.
So again, the monolithic architecture challenges, right? The
Mm,
complexity will
mm.
be more, right?
Right, right, right,
Then the
right.
testing. The main problem in monolithic applications, suppose you are,
Then
yeah, you are just doing one
testing and
small
maintenance.
changes in
Mm,
business layer.
mm.
But see,
Right.
tester don't believe developer, and developer also don't like tester, right? So
Yeah.
yeah, so you tell
Yeah.
tester, hey, I just change one line in business layer. They say no,
Mm,
I need to test
mm.
the whole application. Correct?
Whole application.
So
Right.
see how
True.
much effort is required. But suppose if I break
Mm,
it and I say, yes, listen to me, I just touch this service. You can check the code.
mm,
Other service
mm,
no touch.
mm.
So they will not test the other service, right?
Yeah,
So
yeah.
testing effort will
Mm,
be less, right? Bug.
mm, mm.
Suppose there is
Right.
some bug come to identifying a
Mm,
thousand line of code is very difficult rather than finding in 100 line of code. Right?
right. Right. Right.
Then suppose the tech stack means your things are getting changes so frequently, right? Microservice, message bar. Suppose somebody is want to say I need to upgrade my tech stack. It will take lot of time because you have to carry the whole thing together, right? Because individual
Right.
thing will
Right.
not work, right? So you have to carry
Right.
the whole thing. So that is again a problem. Take update,
Mm,
right? And the releases. I remember in
right.
I think 6 years back or something, I have this monolithic application working. The build itself was
Mm.
taking 2 hours of time, right?
Yes.
We just
Yeah.
put the
Yeah.
build
Yeah.
and we'll go. So see how much problem
Right.
it is. Any problem, any one
Right.
single dot issue in the build, again I have to write, right? So these are the
Right.
main
Right.
problematic area in monolithic. So they can ask this question when you go depth, right? So
Mm.
why do you think the
Okay.
microservice is required? So you have to discuss about these pain
Mm.
areas, right?
Mm. Mm. Right.
See,
Okay.
once I explain it, now it will be in mind, right? Because I am
Mm.
explaining
Right.
in this way. Okay. So now here
Right.
in this picture, I am converting one monolithic to the microservice, right? So what I am doing
Microservices.
is
Okay.
nothing. I break different services. I don't know how many services there. Maybe four services was there. Four functionalities
Mm.
are there. So each functionality
Mm.
I'll put in a different project. In .NET, you can say different
Mm.
project, right? So when I say
Right.
.NET
Right.
project, I can individually build this project, right?
Mm.
Individually I can
Mm.
build
Mm.
any defect come on this project, I'll touch this one and
Mm.
I'll fix it, and this one will go
Right.
for build, right?
Right.
Now in
Right.
this particular monolithic, for user
Mm.
interface there is one entry one exit, right? Now
Mm.
when there is
Mm. Right.
multiple service, so you cannot suppose
Mm.
there is angular, you created this microservice and there is angular
Mm.
UI is there, right?
Mm.
So in
Mm.
angular
Okay.
UI you cannot say, okay, first one, suppose think about this is your e-commerce website, okay? So you say
Mm.
created, I think I have this example e-commerce somewhere, yeah, suppose this one, okay?
Mm.
So suppose
Okay.
I have this microservice, e-commerce microservice. I thought about, okay,
Right.
I need one catalog
Mm.
service. So what the catalog service
Mm.
will do, it will handle all the catalog related things, right? Catalog means
Right.
product
Right.
update, okay, product update, product price change, product image update,
Mm.
something like that, okay? So
Right.
all
Right.
those functionality go to catalog. Then I have one shopping cart, right? Shopping cart is whenever user
Right.
adding anything, the shopping and all, this particular service will
Mm.
take care about that, right? So discount is
Right.
the discount price calculation, and ordering is the last one.
Mm.
Okay. So now
Right.
when my
Right.
web is there, I cannot say my web. Web is suppose Angular or React, right? Say when
Mm.
in your UI page, when somebody is searching some API and all product, you go to catalog, right?
Mm.
And
Mm.
something is they are doing in the adding in shopping and all, you go to shopping, okay? And then
Right. Right.
discount, I cannot say to my web like this, right? Because this
Mm.
thing when I go for Docker and Kubernetes, that time this, see, for a monolithic your IP address are same, right? When you deploy any IaaS and all, you get one IP address, right? This is the dev
Mm.
URL, this is the keyway URL, this is the production URL, right? So this URL
Right.
is fixed.
Right.
But when you go to microservice and then the container, Docker and Kubernetes,
Mm.
these things are
Mm.
automated. Nobody knows, right?
Okay.
Randomly it's created. So for that we need
Mm-hmm.
some kind of a call API gateway. So for the
Okay.
UI, they only know this IP address. Internally,
Right.
it will create,
The
destroy, container, everything, and all these settings. So different technologies are there to handle it. Okay. So it will
okay.
happen in the
Okay.
micro. That's why the microservice is there. Okay.
Right,
So
right,
I
right,
will
right.
go through what is called vertical slicing, horizontal slicing, clustering.
Vertical and horizontal.
So
Okay,
all those things
right,
will come into the picture. The microservice is a full concept, but as of now, you just understand
right,
the basic concept is
right.
this. So for
How
microservice, I
how it is
need
breakdown?
breakdown.
I got it.
Okay, and we
Okay,
need
got
some
it.
one entry point that's why is the API gateway. Okay, and in
APIs.
the API
Right.
gateway, you can do lot of things, right? We can
Hmm.
handle the
Hmm.
security wise. Okay, then
Right,
some
right,
more
right,
concepts
right,
are there. When you go to cloud, we'll explain it. And now they are
right,
saying
right.
one more is there. Sometimes they design in such a way that one microservice, one DB. Okay, this is
Right.
theoretical. Okay, and
Hmm. Hmm.
if your requirement is good and okay, that time people
Hmm.
go for this, but people end up with what multiple service single
Hmm.
DB. Correct,
Oh,
because
okay. Uh-huh.
when you are changing, this is a real example I'm telling. When you are
Hmm.
changing
Hmm.
any monolithic application to microservice, it's very easy
Hmm.
to figure out the different service, and you say I know I need to create a
Hmm.
different project in
Hmm.
.NET.
Hmm.
Microservice
Hmm.
is
Hmm.
ready, but
Right.
nobody will allow to touch that
Database.
DB database is
Hmm.
very
Hmm.
critical. They will say no, this is transactional
Hmm.
data. You do whatever you
Hmm.
want to do in code side database, so you end up with a single DB, right? But
Hmm.
microservice
Hmm.
theoretically say each service talk to a different database. That's why it will be faster, right? But real
Why do you say theoretically? Because in practice, mostly they create a single DB for all the services.
when it's a greenfield application, when you are starting from
Hmm.
scratch, when
Okay.
it's a
Okay.
maintenance, right? The DBA will
Right.
not agree. See, I means the big application,
Uh,
right? 100 tables will be there,
right.
their primary key, foreign key joining, all they'll say, I don't have any clue
Hmm.
how can I divide in multiple databases, right? How the relationship
Hmm.
happen. Because in a monolithic
Hmm.
application, one more advantage is the
That is one. Hmm.
transaction, right?
Right.
Maximum application
Right.
you handle transaction. Now if you break this
Right.
DB, this is called
Yeah, that will
distributed
be
transaction. There is a concept for that
right.
also,
Right.
right?
Right.
Distributed
Hmm. Hmm.
transaction. So this is one more concept they will ask, okay, because they know that whenever they'll ask this question,
Hmm.
if you implement it, then only you're able to answer, right?
Answer. Right. Right. Right.
Suppose
Yeah.
in this scenario I have multiple DBs, right? So catalog,
Right.
yes, it will coming from here. Shopping cart,
Right.
I will put some data in my shopping cart, it will go there, right? Then I'll order
Right.
it,
Right.
right?
Right.
Then order will
Right.
go
Right.
to multiple stages, right? It will go to
Right.
payment, which is a payment service. Then it will
Hmm.
remove the product from catalog so that it will not be available for other user, right? So these are kind of
Hmm.
a
Hmm.
commit. They have a different database and commit is happening. Done. Last
Hmm.
one is
Hmm.
gone. Last one
Hmm.
by chance is break, right? Now you revert
Hmm.
back.
Hmm.
Suppose it's a monolithic
Hmm.
application, you have a transaction
Hmm.
start, transaction end,
Yes.
and
Yes.
in
Yes.
between
Yeah.
rollback commit is done. Easy. But
Right.
how do you handle in
Right.
microservices, right? So
Okay.
when, yeah,
Yeah.
when you
Yeah.
do the maintenance, when you explain this thing to your DBA, they will say, no, I don't want, I want a single DB. Whatever service
Yes.
you do, yeah, this is real I'm saying, right? So
Yeah.
again,
Real. Real. Yeah.
yeah,
Right. That is
so this
true.
is custom. Then people
Hmm.
write
Hmm.
code, the reality is custom basically, right? You say it's
Hmm.
microservice, but not fully microservice. Custom, okay? Something like
Hmm.
that.
Hmm.
Okay, custom is
Hmm.
not a
Hmm.
word, but I'm just saying it, correct? So
Right. Right.
that is nothing but this one. So this is
Right.
how
Right.
we break down a particular monolithic application to microservice. Okay.
Microservice.
This
Okay.
means
Okay.
how you
Okay.
can proceed. And individual
Right.
databases, yes, if you are able to create, that's good. Okay. But sometimes you have to deal
Yeah.
with the single database. Okay. Yeah, there is no other
Okay.
options.
Okay.
Yeah, there is no other
Right.
option.
Right. Right. Right.
Okay, so these are the again the pros and cons, right? The obviously the
Hmm.
advantage is very easy, right? That easy to
Hmm.
maintain and all those stuffs, right? So you can
Right. Right.
hard
Right.
to
Right.
manage. These
Yes.
are the pros and cons. Then
Yes.
this is nothing
Yes.
but your three-tier architecture, which you already worked on it. Is a client, is
Right.
application database, this is a
Yes.
monolithic. Okay, this is just a
Yes.
monolithic.
Yes.
And
Yes.
then this monolithic I break to entire. This is another picture where we differ. I created the microservice breaking. Right. See here,
Hmm.
I have
Hmm.
correct. Here I have one database. Here I
Hmm.
break my databases. Yes. Right.
Hmm.
So
Hmm.
item
Hmm.
database, user database, recipe database. Then it's very easy. See now I
Right.
know. But this breaking, if you're able to do, then
Hmm.
you are good, right?
Hmm.
Then
Right.
the
Right.
whole
Right.
microservice architecture, a lot of things are there. CI/CD pipeline. So that will not touch. We will touch it later. Okay. So,
Okay. Okay.
so the microservice concept is clear. In .NET
Right.
side,
Yes.
layman
Yes.
term, you have to break it and create multiple projects.
Multiple
Because the
projects.
pain
Right.
area you want to solve it was as of now. When I explain the
Hmm.
other things, other thing will come. But as of now, the pain
Right.
area
Right.
is
Right.
build is taking more time, defect
Right.
fixing stuff. So divide the work, right? Break it. When you
mm,
break it, you are
mm,
making a
mm.
container, small container box.
Right,
You know
right,
wherever you
right,
go. So that's why it's
right,
microservice. Correct.
right, right.
And
Got
then
it, got it.
and UI also the new technology came called micro front end, right? Have you heard about micro
Mm.
front
Yes,
end?
yes, yes,
Yeah.
yes,
So the
yes,
front end
yes.
also you can create different component, one in Angular, one in
Mm,
React, right? One in Vue, and you can
mm,
show it.
mm.
Okay. See,
Right,
this micro
right,
front end is not required. So sometimes what
right.
people do just for showcase, they will get the complexity. But you should not write code in such a way that, right? Yeah. Because
Right,
whichever
right,
you able
right.
to do in Angular, you just to showcase, no, I know React and you just do the micro front end. As a good architect,
Right.
you should not think about that way. Correct.
Exactly.
It should
Right,
it
right,
is
right.
required, then use it. The popper tool, right?
Yeah.
The popper
Mm,
tool should be
mm.
there. When there is a screw, you cannot
Right,
use hammer, you have to use screwdriver, right? Something like
right,
that.
right,
So
right,
that
right,
popper tooling is that knowledge will come from practice. Okay.
right,
So now in microservice, the main problem we already discussed, there's the multiple services, right? Now the things come
right.
how they will talk each other. Correct.
Mm, mm,
So you
mm,
think about, you
mm.
already worked on the RESTful web API. Each service is
Yes.
one RESTful web API. You think
Mm,
about this way,
mm.
right? Now
Right, right.
there are multiple services in your whole project, right? And they need to
Mm,
talk each other. Suppose if you go for the e-commerce one, right? So whenever user
right.
just click on the buy button from your, there are multiple services getting called, right? First service is
Mm,
it will
mm,
check the product is available or not, because
mm.
people are surfing for a long time. After 5 minutes, he click on the buy button, so the product may
Right,
not be available, right? So they need to check the
right,
product availability. If product is
right.
available, they will check the shipping, that
Mm,
yeah, shipping
mm,
is
mm.
possible or not on this particular address. Then they will go
Right,
for the payment. When payment is
right,
successfully done, right, then they
right.
will send the notification. There are some notifications are very common nowadays, right? WhatsApp notification you get, mobile notification
Mm,
message that yes, your product is success. So many services are involved, right? So when they will
mm.
ask
Right.
the microservice communication, your answer should be there are two way of communication. One is called synchronous communication, one is called asynchronous communication.
Synchronized.
Okay, so
Okay. Okay.
asynchronous code
Mm.
you already worked on, I believe. Async, await,
Yes,
right?
yes, yes. Wait. Yes, yes.
But that is a code way. But this is the
Mm,
architecture way, right? Because code is inside
mm.
one service. But now the
Right,
service
right,
is in
right.
two different boxes. One service may have Java, one
Actually,
service .NET.
yeah. In some scenarios,
Hmm.
we have consumed REST API from one project to another,
Correct. That is
right?
called
So we have
synchronous.
to.
That is synchronous.
Okay,
That is called
okay,
a synchronous. That's what you did, because this is one service and see service A and service B, there is a direct communication. That means in service A you are consuming service B, or in the service B you are consuming service A somehow. So this
right,
is what you have
right,
done, right? You created HTTP
right.
client, and through HTTP
Mm.
client you are calling it.
Exactly,
This is
right.
called a synchronous communication. Okay.
Synchronized. Okay,
Correct. So
okay.
synchronous communication, the main problem area is it is tightly coupled. Means if somehow
Exactly.
the service
It
B
depends.
is down, your this service is
Mm,
also down. If this is down, this one,
mm.
the whole project itself is down, right? So
Right,
now when
right,
you
right.
understand this concept, right, in your real world
Mm,
also you can match those things, right?
mm,
Suppose
mm,
suppose if I think last day or last week I'm using that I have the HDFC Bank, right? So HDFC Bank, they
mm,
will provide to download your transaction data for 1 month, right? And if you want to go for
right,
more than 1 month, there is another tab where you have to put the request. It's not like
right.
somebody will, it will take some time, right? They're saying after
Mm,
five
mm.
minutes you come. So that is
Yes,
asynchronous, right? Somebody is
right,
doing the
right.
work, right? So
Mm, mm.
they can improve this service. How they can improve? They are asking me, please come after 5 minutes to this page and your report will be
Right,
available. Other than
right,
that, when
right.
the report is available, they can send me a notification, right? Hey,
Notification.
you,
Right.
so that is one improvement. The real time I'm
Available.
saying, yeah, it is
Right,
not
right.
available in HDFC Bank now. I'm just telling you real time, right? So that is called a
Right.
asynchronous, right? So asynchronous
Asynchronous.
means
Right,
services are loosely coupled. Correct.
right.
So now when you say my services are loosely coupled, then how you implement asynchronous? So the asynchronous
Mm.
communication we generally implement through queues. That's called message bus,
Queues.
message queue. You heard about that. And I will tell
Okay, this
you
is
the
where RabbitMQ, Kafka.
Kafka is for Java, RabbitMQ is for .NET. Those are the main two things generally used.
Right.
And in Azure, you have
Okay.
Azure Service Bus, AWS something is there. So all they have the
Okay.
message. The message queue is the solve for the
Right.
asynchronous call, right? So in the
Right, right,
synchronous
right.
way, there are multiple options are also available. So you
Mm,
just use the basic one, which is direct call, right? Another will be called
mm.
poly. Poly is one library, right? Suppose there
Yes,
is,
yes, yes.
yeah, poly you've used
It's
it.
a
So
retry. We can
retry
use
option,
retry.
right? Yeah. Then you
Right.
have called circuit breaker. So many architectures are there,
Mm,
right? So you
right,
should
right,
not be
right.
you. I'm saying you should not be knowing all 10, but when you talk about these two three names, na, people will
Mm,
get confidence. Yes, you
right, right,
worked on that, right? See, 100% is
right,
not possible, and and they don't have
right.
time also for 100%. So all
Yeah,
10, right?
yeah,
Just one and two, and
right,
they'll say yes, this guy know. So like that in
right.
synchronous, asynchronous. Synchronous is the direct call where one service is down means other service is also totally dependent. Here the message queue, right? In case the service
Mm,
B is down, all the messages
mm,
will be stored in the queue. Correct,
right,
and when the
right,
service
right.
B start, it will start processing those queue. So the service A will
Mm-hmm.
keep on working because
Right.
he is not directly dependent on service B. He is dependent on the message queue.
Mm, right, right.
Correct. So this is nothing but the asynchronous communication. These are the concept I'm saying. In the message queue, there are a lot of things are there. Topics are there. Okay, how you will
Okay,
settle
okay.
all those things when you go in the code or maybe separate session and all. Then that time we can explain. But communication is
Mm-hmm.
very important in my microservice. Okay, clear?
Right, right, right. Got it, got it.
Okay. Now
Right.
this is one pattern I am explaining. This is called
Mm,
triangular pattern. Okay. So this one you can give one
okay,
real time example in the interview they're asking.
okay,
So what would be a scenario?
okay.
You can say your current project something like that. This is one monolithic application, and this is
Mm-hmm.
how I done the microservice conversion. So this is conversion. So this
Mm,
is called the
okay,
triangular pattern. Okay. So the triangular
okay.
pattern, what is happening? See that these are the first time the monolithic is the full application, right? So from the
Mm,
monolith,
right.
you figure out only two services. On
Two
those two,
services.
you
Okay.
implement the microservice, right? And so the
Right, right.
monolithic code is getting reduced. So like that,
Reduce.
slowly when
Right.
the time goes, the monolithic will be
Mm,
reducing and the more services getting
more
added. So
services.
this is called
Right.
triangular pattern. So through triangular
Mm,
pattern,
mm,
I convert my monolithic application to your
mm-hmm.
microservice. Then the next question
Right.
comes, suppose in this particular scenario, right? You have couple of
Mm,
services, you have
mm,
couple of code in monolithic. How do you
okay.
make the communication? They will ask this question,
Mm,
right?
mm, mm,
Because your
right.
user, you cannot say your user, hey, for this service you go to here, for this service you
Mm,
go to the old code. You cannot say your
mm,
user, right? User only need one API, sorry, one IP address or
right,
one
right,
URL. So how do you
right.
handle this problem area, right? So to solve this problem area, you should have something here, facade or some kind of interface, right? So those
Mm,
interface
mm,
code will throw away. Throw away means
mm.
once you reach to your destination, that code is no use, right? Because all
Yes,
your
yes, yes.
call will go here. But unless that
Right.
section is ready, you
Mm,
create
mm,
some code, temporary code,
mm,
which is nothing but the interface, which will have the
mm,
logic. Okay, suppose I created
mm,
my order service and payment service is microservice, and my
right.
catalog service is monolith. So I'll check if it
Mm.
is order service or payment, I'll send it here, and if it is
Here,
catalog, I'll
right,
send it here. So
right,
abstraction is there.
right,
User will not, yeah,
right.
user will not able to know what is happening, right?
Got
Suppose
it,
some
got it.
construction work is going on, they'll put a boundary, right? So the outside
Right,
people don't
right.
see what is happening inside. Inside, a lot of things are
Mm,
happening. So that code you can
right.
say is throwaway. So when you talk in this way, yes, you have really implemented that, right? They will not go in
Mm,
depth what
mm.
will create interface because
Right,
they don't
right,
have time. Once you talk in this
right.
way, so triangular pattern we
Mm.
generally use when you convert a monolithic application
Convert them on
to
to microservice.
microservice,
Right,
right?
right, right, right.
So I actually implemented this one. We created it as
Mm,
that's called a throwaway code, right? So the product
mm,
means who is the client, who is paying money. He's
mm,
saying
mm,
you are doing this work, junk work, and my money is getting, but this is wasted, right?
mm,
Because he's not technical guy,
mm.
right? But there
Right,
is no
right,
other way
right,
you can
right.
do. If I don't create the interface which is throwaway code, how do I communicate, right? Then I have to say,
Yeah, yeah.
then what I have to say is I have to say
Two,
yes,
two application.
two application,
It
correct?
will not.
And
Yes.
yeah, two application, and that architecture wise is
That
not
would be
good,
messy. Still
messy,
messy. Yeah.
yeah, and you are breaking the
Right,
agile methodology, right? Agile, what you say,
right,
slow development and testing, right?
right,
So when I
right.
keep this service open, see there, suppose two are green means these two are active, means people are using that,
Mm,
and these are still development. So I am keep on
right.
adding it. It's a production ready, right? Because end of the day when I say okay, switch on off, that is not good way. When I
Mm,
switch on, I see
mm,
all my services broken, I wrote some wrong code, right? So I'm
mm,
not
mm,
following the
mm.
agile. This is the agile way. I'm keep on
Right,
making some services active. So I have to create the
right, right.
interface so that both way the traffic goes. I can
Right.
handle this way that less traffic is this way, more traffic is this way, because this is testable
Right.
code, right? Something like that.
Right.
So
Right.
this is
Right.
nothing but
Right.
a triangular pattern.
Right. Okay.
Okay.
Yeah.
Then one more pattern we
Circuit
have
breaker.
called circuit breaker. So this is also very important.
Mm.
Netflix, I think they have created this one. Okay, this is called the circuit breaker pattern. So circuit breaker
Mhm.
pattern is something I think you have already see many times, but you didn't
No, I
understand.
just know that I just saw the name, but I don't know what
Means
it is.
suppose you are going on URL, right, and you see that
Right.
keep on running is happening. Okay, after suppose 2 3 seconds, the
Mm.
page is broken. Okay, something like that. So
Right.
what is
Right. Right.
happening?
Right.
Maybe the inside there are multiple microservices there. One service is
Mm.
failed or one service is down, right? So the whole
Right.
application is got blocked, right?
Mm.
So the
Mm.
circuit
Mm.
breaker name itself, it came from your the electrical thing, right? There was circuit breaker,
Mm.
electrical
Circuit
switch, right?
breaker.
When something wrong happen,
Okay.
it automatically switch off. Same thing here, right?
Mm.
So any
Mm.
service
Mm.
is down, right? It will
Okay.
not go to the other service. See that? Right? So here
Mm-hmm.
the communication is a normal flow. In the circuit breaker flow, see this service is not going to another
Mm.
SB. It is just giving the response as error. Okay. So my point is I saw some of the URL where there is no proper error. Just the response then 500 error. Means
Mm.
broken.
Mm.
Your whole application is broken. Rather than that,
Mm.
you can see error message,
Mm.
application down, something like that. You can only do that through
Mm.
circuit breaker, right? Because your circuit breaker
Mm.
knows this application is down. There is no point to keep on going here, right? It's a waste of
Mm.
time.
Mm. Mm.
Right.
Right.
So that's
Right.
why the
Right.
circuit breaker pattern is important here. You will reduce the time because you don't know. You always think positive. Okay, I go one time maybe
Mm.
fail. I go second time it may up. I go third time it may have something like that, right? So circuit breaker logic
Mm.
is this. We have lot of complex logic they put here, right? That try for four
Mm.
times, fourth time is failed, then only you send the error message to this one, right? Correct.
Right.
Or
Right.
some kind of mechanism where it will trigger a mail to the admin people, hey, this service is down, rather than showing the
Mm.
error message to the user 500, right? So the circuit breaker, how to
Uh,
implement it?
I
Hmm.
Yeah, that is where I am coming to. Yes. 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 Yeah. Please
Okay, so
go ahead.
circuit breaker, how to implement it? That is called the health check, right? In .NET API, have you used PROBE endpoints? I think you never used it.
No. No.
Okay, so
No.
whenever
No.
you create microservices web API, right, we create one endpoint
Okay.
called PROB, just the REST endpoint.
Mhm.
Because in market there are multiple libraries are there. You have to just include those libraries, and libraries has a
Mhm.
mechanism you can set up like every second, every 5 seconds, they will hit that probe endpoint, which let the library
Okay.
know my service is up or down. Right. So suppose
Right.
couple of
Right.
couple
Right.
of endpoint call they are not able to get, then they will update the service down. Right, because when they
Mm-hmm.
create
Okay.
microservices, right, they create a lot
Mm.
of infrastructure. There should be a dashboard, okay, where all the
Mm.
microservice health will be available, right? So how they will track those
Mm.
health? Through the health check. That's called a
Mm.
health check,
Mm.
right?
Okay.
So
Okay.
that's why
I
I say it's
understand.
it's a huge thing. If we go each and every
Mm.
topic through code, it will take a lot of things, okay, but
Mm.
very high level I'm
Mm.
covering so that you can explain. Okay.
Right. Right.
So
Right.
circuit
Right.
breaker one of the pattern. So you can easily say, yes, I have
Okay.
used it. How you used it? I just create one
Mm.
endpoint called health check. Okay.
Mm. Mm. Mm.
And that's how
Right.
I done
Right.
it. So what you did, suppose if I say my health check is bad, I'm just sending one error message. I create a error page, custom error page.
Yes.
Hey, the application is
Yes.
under maintenance, something like that. It was not throwing
Mm.
500. That user will not have
Mm.
any idea what is happening, right? So this is the
Right.
better
Right.
way of
Right. Right.
handling errors, circuit breaker pattern.
Mm.
I think Netflix
Right.
has created this one. Okay.
Okay. Okay.
Then
Okay.
one more architecture. This one will cover. Okay. So then we'll end
Okay.
this session. So what is this one?
Okay.
This one is one more microservice architecture pattern, which is called BFF, backend
Okay.
for frontend. Means I
Okay.
have the microservices. Suppose the product catalog example. Okay. So this
Right.
microservices product catalog where I have an e-commerce website. This will give all the product. You search the product, images will come, description, price, right? So all those details coming from this
Right.
microservice. Clear?
Right.
Now,
Right.
this data, this RESTful web
Mm.
API which you created, it is sending the JSON data, right? That's what you already did. You created
Mm.
on RESTful the JSON
Yes.
data,
Yes. Yes.
and it
Yes.
has all the
Yes.
product
Jason.
data, right?
Right. Right.
Now if I make it more complex, if I say your data is storing in a document DB, right? Then your JSON structure I
Mm-hmm.
can also change, right? Because in the single JSON
Mm.
itself,
Mm.
right? Suppose the product
Mm.
is TV, your JSON structure is different,
Mm.
right? Suppose your product
mm,
is
mm,
a pen, example, pen selling, right? So your
mm,
JSON structure is different. Means the description will be
mm.
different for
Right,
TP left,
right.
different parameters. That's how the Amazon shows, right? Different parameters will be have pen. Those parameters are not applicable, right? So based on the product,
Mm,
your response change. Correct.
mm,
So this
mm. Right,
microservice is
right,
handling all those things. Okay. Now
right.
that's I'm talking about the product side. Now think about that particular you created one React JS which is for a desktop
Mm,
application. You created one React Native which is for mobile application, right? Like Amazon. Amazon you
okay.
can open in web.
Mm,
Amazon you can open in mobile also, right? The same
okay.
JSON which this microservice is creating, you cannot
Yeah.
send the same JSON to your React JS code and same JSON to your React Native code. You can send it, but that's a not a good way of doing it. Correct? Because whenever
Okay.
you are developing any React Native or mobile application
Mm,
iOS,
mm,
your thing should you should
mm,
think about from the bandwidth side, right? Because the
mm,
mobile bandwidth
mm,
less, so
mm.
you have to manage with the less JSON structure. Maybe the
Less.
JSON object which you are sending to web, it could be 5 KB example, but for mobile you have to
Right.
manage with the 2 KB. Now the same REST
Mm,
endpoint, how do you handle it? It's not possible.
mm,
So that's why you need two different component on front of your microservice. Mainly
mm.
they will do different API gateway. One API gateway for desktop, one API gateway for mobile. So for desktop the URL will be
Right.
like this, like www.amazon.com, right? So that's why you go to Amazon
Right.
website. But when you open the Amazon
Right.
app, you don't know where which URL is going. Obviously it will going to a different URL, not same, right? So this is
Mm,
called the
mm,
back
mm.
end for front end. Means this is the back end for
Right.
this front end. This is one way of
This front
microservice.
end.
Yeah,
Yes,
this
yes.
is my
Got it.
front end, this is my
Got it.
back end. So
Mm,
this is back end is for this
mm,
one, not for microservice. So microservice will give the
mm.
same data. Maybe you will customize those, remove unnecessary data from the JSON and send it to you. Just one example I'm saying. There could be multiple things, right? Because mobile, the
Okay.
screen resolution will be different, right? So maybe different. You will
Mm,
send different
right.
images, and here you will get different
Mm,
images. Like lot of
right.
scenarios are
Right.
there based
Right.
on the requirement. When you do the
Right. Right.
brainstorming and all those stuffs, right?
Mm, mm.
So
Got
that
it.
time
Got it.
it will come. So this is one way
We
of
will determine. Yeah. Yeah.
correct. So
Right.
why I pick up this one is because see these are the thing, because these are the thing you can easily explain and we can implement it easily, explain in the interview
Mm,
also. Yes, I created a
right.
RESTful web services. I have one Angular, okay, and some
Mm,
other team was
mm.
working on the React Native application. You are not a React Native
Right.
guy, right? You can say other people,
Mm,
but I
mm,
created
mm.
this two different services. One is for this data. Why you created it? I created it because of this reason, right?
Right.
JSON structure was more. It was 5 KB for the desktop application, and they told they need less data, the mobile team, because of bandwidth. So I need to customize the
Okay.
data, and I created. So this is
Right.
so what architecture you did for the other backend for front end architecture I implemented, right?
Right. Right. Got it. Got
Correct.
it.
So once they
Yes.
explain only these two, three kind of thing, they will say, yes, you have worked on. Okay. Then
Mm,
obviously
mm.
when you do the real implementation, the technical call will come, right? Okay. How do you
Right.
implement
Right.
it, that service, this one, what kind of library you use? Okay.
Mm,
Any kind of library. So many libraries are also easily available, but concept you have to understand.
mm, mm, mm. Got it. Got it. Got it.
Correct.
Yes.
So
Yes.
these are the microservice concept and architecture. Tell me any doubt you have or not.
Yes. So far clear.
So far is clear, right?
Yes.
Okay,
Yes.
so you go through the recording. So let me stop the recording.